Hi everyone. This lesson and its series of videos is going to walk you through page 11 in the packet, which is an extension of what we did on page 10 in the previous lesson. It's actually kind of important that you have done all of page 10 to ensure that you have the necessary foundations for page 11, because many of the questions are going to ask you to reflect on the answers that you got on page 10 and to understand where it came from so that we can take some much needed shortcuts. If you did page 10, either along with the videos or by yourself, you probably realized there were a lot of really tedious calculations, things that just took a really long time. And while hopefully those things made sense, I do want to be realistic that those were not necessarily very practical ways of solving problems that involve percentages, and that we really do have better, more efficient ways to do them. And that's what page 11 is all about, kind of cutting through some of what we were doing to get to the parts that are the most efficient and practical. So before you start this video, please do make sure that you check over your own work for page 10. Make sure you have all the answers, and make sure that the answers that you got made sense so that when we build on them on page 11, you'll have something that you can latch onto. For example, in question number 3, it says to consider the multiplier you used in your answer to number 2, letter G. That means we need to have the multiplier from that problem so that we know what this question is asking of us. I'll just quickly make a note to myself, because if you're watching this on a separate day or in a different sitting and you forgot your multiplier, you might have to flip back. The multiplier I got in number 2, letter G, which I also wrote in number 2, letter F, was 1.1. And I went into detail in the videos for that lesson on where 1.1 came from, but let's remember that the multiplier that we got from that past lesson was 1.1. This is asking for a more efficient way to figure out that the multiplier was 1.1 without having to do all the steps in parts A through D, because that really did take a long time. If you think back, in parts A through D, we had to figure out Monday's total till we could get Tuesday. Then we had to do Tuesday's total to get Wednesday. Then we needed Wednesday's total to do Thursday. Thursday's total gave us Friday. I used a bunch of scratch paper at the time. It took quite a while, plus a calculator, to be able to do all of this. It was tedious. And there is a better way. I'll challenge you, if you can think of a better way, to try to come up with one. But if you don't feel you really know how to, I'll talk you through it. If you feel like you can do it on your own, feel free to stop this video and move on. But here's what I would have thought of. 1.1 technically could have a 0 at the end of it. And if you're saying to yourself, well, who cares, Herbert? It didn't have a 0. Why would you put one there? Here's why. When I think about a problem that has a multiplier, I actually don't normally do all of this work. I mean, we can, don't get me wrong, but it's not my preferred way. As most of you know, I like to try to be efficient. I like to try to get to the point as quickly as I can. So this usually is what I think of when I think of percentage problems. I think of that jackpot question, and I think of something like this. On Monday, we have 100% of our jackpot. We have all of the money available to us. On Tuesday, we have all of that money available to us, all 100%, plus 10% more, because it built up overnight. It built up and increased by 10% more. So I like to think about this and think, wait a minute, okay, for Tuesday, I had 100% of the money initially, plus an extra 10%. So I'll talk you through that calculation here. I'm figuring I had 100% of what I had initially, plus 10% more. And if I think logically and add those percentages together, 100% of what I had initially, plus 10% more that I'm increasing by, would give me 110%, which, not coincidentally, if you think about as a number, 110% has a current decimal right there at the end of the number 110. if I convert this convert this decimal by moving 2 places to the left like I was doing before, notice what that gives you? 1.10, which is the same multiplier we calculated the long way. So instead of doing all of those individual calculations, I could have actually just thought really logically that if I took 100% of the money that I started with and increased it, added 10% more, that gives me a new increase of 110%, and 110% is 1.10. So I could have predicted that the multiplier was going to be 1.10. I didn't have to do all that work and work and work and work and work to get there. I could have just known it was going to be 1.10%. So that, in essence, is a major shortcut that we can take when we do multipliers. Simply take 100% of what you're starting with, plus whatever percentage you're increasing by, and that new number, that sum, represents the multiplier that you'll want to use. You just have to convert that multiplier to a decimal by moving to the left 2 places. So in question number 4, it says, well, what if the money decreased each day? That'd be a terrible lottery if we were decreasing each day, but think about it logically. If I started out with 100% of the jackpot, but I was decreasing by 10%, naturally I wouldn't be adding to the jackpot anymore. I'd be subtracting to the jackpot. I'd be subtracting 10%. And let's think about that logically. 100% minus 10% would be 90%. And if I take that number 90 with its current decimal and move the decimal 2 places to the left, that gives me 0.90. So the multiplier for a decreasing situation would be 0.90. If I actually did the long way, it would work. I'll prove it to you with just a couple of examples, but if you wanted to see it, this is actually what would happen. Let's say on Monday I started with $1,000, but instead of the jackpot going up, the jackpot goes down on Tuesday. If I wanted to figure that out, I would take 10% of what was in the jackpot, that's $100, and I would subtract it from the jackpot that I started with. Whoops. 1,000 minus 100 is 900. And if I think about this logically, notice something. To get from 100 to 900, or 1,000 to 900, I could do 1,000 times the multiplier 0.90 that I found. Yep, that gives me 900. So I could even predict that on Wednesday, if the pattern continued, 900 times the multiplier of 0.90 would give me $810. Now I don't even need to bother doing calculation. I can predict exactly what Wednesday's jackpot is going to be. And if it's going to decrease again, I can take that number times 0.90, and I can predict that the jackpot is going to be $729 on Thursday. And I can save myself the time from doing all those individual calculations. Now, all that to say is that we now have a method for writing a multiplier without having to do a lot of work, without even needing scratch paper. The general method is to take 100% of what we're starting with, plus or minus whatever the new percentage of increase or decrease would be. So I'll write it as kind of a formula here. When it says use the method, let's call this the method. 100% plus or minus, if it's increasing or decreasing, whatever the percentage of increase or decrease is. See if that makes sense. And if it does, see if you can try number 5. If you don't feel like you can do number 5 on your own, I'll walk through a few examples of number 5 in the next video, but challenge yourself. See if you can try it using this technique.